let's take a quick look. Why don't you get out your notebooks? If you need some scratch, if you don't have one yet, and that's, just get one right away. But if you don't have one, grab some scratch paper. Got some right up here. Oh, okay. Okay, so what I want to do today, I just want to let's kind of quickly review where we are. And I know a lot of people are still working away on that first assignment, and that's fine. That's where I expect you to be. I think a handful of people have finished, but that's really ahead of where I'd expect you to be at this point. The first two assignments won't be due until Sunday night at 11 p.m. So you've got lots of time to work on them. We'll get in the lab here right away today. I don't want to spend a lot of time with this. We'll probably come back tomorrow and kind of touch base again on this same topic, just briefly. What we did, just in brief review, remember what we've been talking about. We've been talking about how to simplify, yes sir, yes ma'am, sorry.
Did you say we have two?
Two assignments, yeah, this one I just put up, you haven't seen it yet. The second one, the one you started yesterday was I think called Orders of Operations, yeah. The next one is gonna be solving for one variable,
So
okay?
you have to do both by Sunday?
Both by Sunday, yeah, and they're pretty short. I mean, I think you can get them done at school, I really do. You may have to do a slight amount at home, but I kind of doubt it. Yes, Ruby?
What if some of them are saying that they were wrong?
I'll fix them, yeah. I know kind of bear with me here. I was gone for a year and the Moodle sort of went to pot while I was gone. I'm working with people to kind of get everything up and running properly, but there may be a couple weeks where there's going to be a few little glitches here and there, but I can always deal with it. Just let me know. I can give you credit for those. No problem. We'll take care of it. Today, in fact, when we get down there, remind me. I want people. Maybe I'll just call people up and I want to make a detailed list of anybody that had one that didn't work properly. Tell me, and I'll go in and give you credit for it. So no sweat. And they'll be fixed before we take the tests. Guaranteed, it'll be fixed. So. We were looking at how to simplify or evaluate expressions using order of operations, right? We did things like, let's just take one quick example. If we had something like this, how about? What's our thinking? What do we probably want to write down on the side of our paper before we even start on this? Okay. Yes, ma'am.
Little PEMDAS.
The PEMDAS. Okay, now how do we do that?
Tree form.
Yeah, tree form. So what goes first? P, E, oh good. M, N, D,
A, S.
A, and S. Good. And so what we've done so far, if we are simplifying, we always go top down, don't we? Start with parentheses and work our way down. So let's take a quick look at this. This is kind of a tricky one. How are we gonna approach this one? Say it again. You're saying these parentheses, or are we gonna add some parentheses? We're gonna add some, aren't we? First thing we want to do is, if there are implied parentheses, we want to add those so we can see them, right? Where are there implied parentheses on this one? Top and on the bottom, right? Remember what we said about this. When we have a big fraction, big ugly fraction, with lots of stuff going on top, lots of stuff going on the bottom, we need to take care of the entire top and the entire bottom before we can actually do that division, right? And so we need to put these implied parentheses on the top and on the bottom. Now this is just kind of a minor point, but I think it might be helpful. How come I made those parentheses, do you suppose, like a bracket instead of rounded parentheses? What do you think? I could do it either way, but is there any advantage to this? And making them purple even helped a little bit too. guess why I might have done that? I did it for a reason.
Easier to see.
Easier to see, true. And why on the top would that be an issue?
Because
There's already parentheses there, right? We already have a set of parentheses, and so we want to be able to distinguish the inside parentheses from the outside parentheses, and so I made them different, right? On the bottom, we don't need to do that because there aren't any parentheses. Now let's go ahead and start on the top. When you see parentheses inside of parentheses, where are we going to start? On the inside, aren't we? Right. Because we have to do everything inside that top block has to be taken care of. So looking at the top, we're going to apply the whole PEMDAS tree to just the top of that fraction, right? So what do we do first on top then? Yeah, inside the parentheses. What do we get?
5.
5. Okay, so we can replace that with a 5. Okay, and on the top, we check off parentheses. Okay, what's next? Yeah, there are no exponents on top, are there? Right? So multiplication. What multiplication? 5. 2 times 5 is 10, right? So we end up with, on the top, we've just got 10 plus 8. And I can write those parentheses, but do I really even need them anymore? Not really, right? Because now that's just going to give me 18 on the top. Okay, good. What about the bottom? Okay, I've got I don't have any parentheses inside the bottom, right? But I have an exponent, 2 squared, what's that? Okay, so I can replace that with a 4, and then I just get 4 plus 2 is what?
6.
6, okay, good. So now I've worked my way down through top and the bottom, and there's only one step left. Division, okay, that makes sense? So divide 18 by 6,
3.
and we get 3, okay. Now that's a pretty hard one, because we had stuff on top and on bottom, there's some implied parentheses, and you'll get some of them like that on the practice. But the point I wanted to make here was, this was really important to us, right? This order of operations tree, but we work top down. Okay, now, that's not the end of it. The next thing we want to look at is how to solve equations, okay? Now, we're going to focus on how to solve equations with a single kind of variable. So we're not going to solve equations with both x's and y's, or x's and y's and z's, or anything like that. We're just going to have a single kind of variable. All x's, maybe all y's. It doesn't matter which variable it is, as long as there's one of them. So real quick, I mean, this is kind of, I don't mean to, we're going to start slow. It's easy introductory slide here. An equation is just a statement in which we have two expressions that are set equal to each other, right? So which of the following of these, A, B, C, and D, which of those are equations? A and D, right? What's wrong with B and C? No equal sign. These are what we would just call expressions. It's like in English when you study sentences, it's like a phrase versus a sentence, right? A sentence has to have a verb in it, a phrase doesn't have to have a verb in it. If you're an English type person, there's an analogy for you, but you probably don't need it. These are lacking an equal sign, so it's just A and D, okay? I'm gonna skip this. I really, in hindsight, I don't think we need all that stuff. I'm just gonna jump right to an example. How would we go about, you suppose, we'll start easy here. How do we go about solving something like this? We'll go really easy at first. You know how to do this intuitively. Yes, sir. I want to get the x by itself. Good. When we are solving an equation for a variable is exactly the same thing as isolating the variable. This is a hugely important statement here. I'll say it a million times this year. If you have an equation and you can point to a single variable, you can always isolate it. And that means solve for it, right? So here's our variable that we're trying to isolate. Once we get it by itself, we have solved for it, okay? Now the trick is, how do we execute those steps in order to get the variable by itself? Now really, this is like what we talked about the other day. If you didn't know algebra and you're trying to get that x by itself, you can probably see that there are two things you got to do to get the x by itself. We got to get rid of the 3 and we got to get rid of the 2, right? The 3 is being added, so how would we get rid of that? Subtracting, right? Addition and subtraction undo each other. The 2 is being multiplied, so how would we get rid of that? Divide. Multiplication and division undo each other. But the issue here is, in what order? Do we divide first and then subtract, or do we subtract first and then divide? And you guys all know that. I mean, you've advanced through to this point, so you obviously know that, you know how to do this. But do you know a way that you can always know for sure what the next step is when they get harder? Well, okay, when we're done, we can check it. You're absolutely right. But how do you know which step to do first, other than just because you've done this a bunch? That's it. That's the trick. And you probably already knew that, but that's a huge one. You just do PEMDAS backwards. So the order of operations tree is such a big deal. I mean, you get so much value out of this. If you know how to use this well, it's easy to do, and it takes care of most of algebra, all right? So to simplify, we go top down, but to solve or isolate, we go bottom up. It tells us exactly the order in which we have to do things, right? So first would be, we're going to undo adding and subtracting by the opposite. So what's the first step going to be then? Yeah, first step is we're going to subtract 3 from both sides, right? And that takes care of that one. And we just get 2x equals 6, right? Next step, divide. We want to undo the multiplication by dividing. And so we get x equals 3. Now, Ruby pointed this out. This is huge also. There's another free benefit to solving equations. Anytime you get a math question that asks you to solve for something, sometimes it's harder to do. The question might be harder to do, but you can always know if you got it right. How? Plug it in. Yeah. When you're all done, you can always know if you got it right. Take the answer and plug it back into the original equation and see if it works. If it does, you did it right. If it doesn't, you didn't. And that means just go back and try again, right? So in my mind, there's really no reason to ever get one of these wrong on a test, unless there's one that's just so hard, you just, you know you got it wrong, but you can't figure it out. But that's rare. I think in most cases, if you know you got it right or wrong, you can go back and maybe figure it out, okay? Let's try it. If I plug the 3 back in, does it work? 2 times 3 is 6, plus 3? 9 equals 9. Check, we know we got it, for sure, right? Okay, let's do another one. A little harder one. Let's try something like this. What if we've got, oops. Try that. Real quick, just scratch that one out. Start off by writing your order of operations tree, and we're solving, so we go bottom up. lots of really good stuff there. Now, there's something I wanna talk about with this one. There's two ways you can do this. Now, let's see, remind me your name. Drew. How'd you do, I think I saw you do it one way. How did you approach this? You did a good job.
I multiplied 2, 3, and 4 with parentheses.
Okay, so you started off by distributing the two. Most people that I saw, tackling this one correctly did it that way. That's fine. We always have the option with the order of operations tree here of before we solve, we could try to simplify things and make things easier. So we could start off working our way down until we get where we want to be, and then solve for x and work back up. Okay, that's fine. We could multiply the 2, we could distribute that 2 through, if we want to, and get 2 times, what do we get if we distribute
6x.
6x
Minus 8.
minus 8 plus 4 equals 38. Now what?
Just subtract 8 and plus 4.
Okay, good. Then if we're gonna simplify, we might as well finish it and combine like terms, right? And these guys would combine to give us, everybody see that? Negative 8 plus 4 is negative 4, so we get 6x minus 4 equals 38. Now it's pretty simple, isn't it? Now, what are the 2 steps in order going to be to get the x by itself? First, we add 4, good. And then divide by 6, right? Make sense? Okay, so doing that, adding 4 gives us
42.
Dividing by 6?
7.
7. That works, that's great. Now there is another way of doing this, and I saw just a couple people do it this way. This works fine. I personally would have done this a little differently. I'll show you what I would have done. Not saying this is wrong, it's fine. I want you just to realize there's another way to approach this. And in math, I really want you to resist the temptation in math to say, oh man, why is he showing us another way? That's really not the way to approach math, honestly. We'll spend a little time, maybe tomorrow, Fridays are good days for this. We'll talk just a little bit about kind of what math is as a system and how it's so valuable and how you learn to be good at it. Math it's amazing. It's completely self-consistent, and the more you understand that you can take multiple paths to get to the same place, I think the more interesting it gets and the better you get at it. Another approach to this that is completely equivalent, but just using kind of a different way of thinking about this, would be not to distribute. Let's just start immediately, because I can already point to a single variable there. I should be able to isolate it by just working backwards, okay? So let's just do that. Let's just jump right into the solve mode and do that. Now notice when I'm solving here, I don't get up to the parentheses until the last step, do I? Right? So when we're talking about undoing addition and subtraction here, we're talking about not the addition and subtraction inside the parentheses, because the parentheses, we don't tackle those until here, right? So when they talk about undoing addition and subtraction, which one are they talking about then? Right? When we're trying to isolate the x, first we have to work outside of the parentheses. So really what this means is we're going to undo any addition or subtraction outside of the parentheses. So let's just ignore the parentheses, cover those up. What do I have to undo? Yeah, I got to undo the plus 4, don't I? Right? So outside of the parentheses, the first thing would be, step 1 would just be to subtract, or step 1, subtract 4, right? Everybody agree? Okay, so we end up with then, when we do that, those cancel, and now we just get 2 times the quantity, and that's how we describe that, by the way. I want to make sure that I always model the proper way to talk about this stuff, because it sure makes math easier if you can think about and talk about it that way. Something that's grouped in parentheses we would call a quantity, okay? 2 times the quantity, 3x minus 4, and that tells us that it's one big thing. Treat it as one thing for now. 2 times 3x minus 4 equals what?
34.
34. Okay, good. Now we're set up for another step. We advance up the tree. Is there any multiplication or division outside of the parentheses we need to take care of? Yeah, the 2 is being multiplied by the parentheses, right? So we can undo that. How? Divide by 2. So step 2 would be, let's divide by 2, right? There's step 2. The 2's cancel, okay? And we're left with 3x minus 4 in parentheses. Do we really need the parentheses anymore now that they're by themselves? No, once we get the parentheses by themselves, we can just get rid of them, right? So we get 3x minus 4 equals 17. And so we skipped through the exponents. There weren't any exponents. And now we're up to the parentheses. Okay, once we get to the parentheses, if there's a lot of stuff going on, what do we have to do? How do we deal with all the stuff in the parentheses? Start over with PEMDAS, right? So now, how do we deal with this? What are the 2 steps in order? I want you to think about this as a group. What are the 2 steps in order to get the x by itself? First, we add 4, and then divide by 3, right? That's it, okay? So let's try that. Last step. Plus 4 gives us 21 and 3x, right? And then divide by 3, you said. So we get x equals 7. So we'll call that step 3, and that really was just the combined parentheses steps, right? How do we know if we got it right? Check it. Plug in 7 and see if it works. What's 3 times 7?
21.
21 minus 4?
17.
17, so that whole thing is 17 times 2?
34. 2 times 17 is
34. Plus 4? Check, we got it. How about that? Okay, we good? Last one, and then we're out of here. How do we feel about this, by the way? Did that make sense? The second way of doing it? Okay. Here's my challenge to you. I want you to try on the assignment, even if you were very comfortable doing that the first way, I want you to try a couple of them without distributing, let's say. Try a couple this way too, okay? Last one, there's one little other tidbit I need you to know about, and then we're absolutely good to go. How about this one? What if we have something like 2 times the cube root of 8 minus 11 equals negative 7. Oops, sorry, cube root of x I want to do, not 8. Do something different. Hang on. Yeah, let's see, equals, yeah, we'll do negative 7. How about that? Okay, that's weird. It's a little bit weird, because that radical doesn't seem to fit. But what does a radical count as in our order of operations tree? This is kind of a trick.
Power.
It's a power. Yeah, it's an exponent. Okay. Here's why. Write this down. We're going to learn, you may have seen this before. If you haven't, it's okay. You're going to see it in Algebra 2 for sure. But this is something we just need to be aware of at this point. If I have something like a square root of x, that's the same thing as saying x to the power of 1 over 2. Okay? We're not going to necessarily do that now, but we just need to know that that's how we treat it. If we have a cube root of x, that's the same thing as x to the 1/3. And the pattern is, and you might see this, is that whatever the little number is, the index of the radical, that's in the denominator of the fractional power. With a square root, there really isn't a divisible 2 there. So does that make sense? We don't have to know that, but it is a power. So for order of operations, that's how we treat it, okay? So going back up here, to this problem then, how are we going to tackle this using order of operations? What's the first thing we got to do? Okay, so we got to undo subtracting 11, right? How do we do that? Add 11. So first step, add 11. Okay, those go away. Step 1 gives us 2 times the cube root of x equals what? 4. Okay. So there's step one. Now what? Divide by two, right? We gotta undo multiplication or division. So step two is divide both sides by two. So the twos cancel, right? And then we're left with the cube root of x equals 2. Okay, so now that's our exponent, isn't it? That's the last step. Now, how do we deal with that? How do we undo a cube root? Yeah, you cube it, right? And once again, that's kind of an advanced topic. You know, we're not going to do a lot of this kind of thing this year, but next year I want to set you up to be prepared to know how to do this stuff. So yeah, we undo a cube root by cubing both sides, okay? And that's our exponent step. So what is the cube root of x cubed? Yeah, they undo each other, and I just get x equals, what is 2 cubed? 8. Okay, let's check it. If I plug 8 back in, the cube root of 8 is what, yeah, it would be 2, wouldn't it? Because 2 times 2 times 2 is 8, so that becomes a 2. 2 times 2 is 4 minus 11. Yeah, we get -7 equals -7. Check. We got it. Okay, questions? All right, let me find a place for us to go here.